Hello, we are going to talk about predicting precipitates and solubility of ionic compounds in water. So there are a set of solubility rules for ionic compounds. The set that we are using is based on our textbook, and it is a series of 5 rules. So using these rules, we can predict which ionic compounds will dissolve in water. So which ones are soluble and which ones are insoluble, meaning they do not dissolve in water. These rules are used when a reaction happens and one of the products might be solid or might be aqueous. We can determine which of those states of matter it has. Or if we're putting an ionic compound into water in hopes of making a solution, this can give us some guidance as to whether or not that will actually happen. Finally, these rules aren't perfect, especially our set. If you search on the internet for solubility rules, you are going to find a wide variety of different types of charts containing this information. They have varying degrees of how specific they are, and ours are fairly general, though will be useful for most of the compounds that we'll run into in our course. So rule 1, the compounds that this is relevant for are salts of alkali metals and ammonia. So that means in group 1A, any salts including sodium, lithium, potassium, anything out of 1A, and then the ammonium ion. These are soluble. The exception are some lithium compounds. So most of these salts, almost all of them, are soluble. The exception is some lithium compounds. Rule number 2. The compounds that we're interested in are nitrate salts and chlorate salts. They are generally soluble. Nitrate salts and chlorate salts, we're looking at the anions for this case. Nitrate and chlorate are anions. These are typically soluble, and there are very few exceptions for these. Nothing worth noting in this case. Rule 3 refers to sulfate salts. These are generally soluble. There are exceptions, though. 6 different chemicals that we need to consider. Lead, silver, mercury, barium, strontium, and calcium. These are not soluble. So if you have lead sulfate or silver sulfate, that is not going to dissolve in water. So again, sulfate ionic compounds, including sulfate, are usually soluble. However, the exception, they are not soluble when one of the anions are on this list of lead, silver, mercury, barium, strontium, and calcium. Rule 4, chloride salts, so Cl negative, and these typically apply to most of the anions from the halogen row. They are usually soluble. They are not soluble when they bond with lead, silver, and mercury. So again, usually soluble. However, when bonding with one of these 3 cations, they become insoluble, meaning they don't dissolve in water. Rule 5. This is a kind of range of different anions. We have carbonates, phosphates, chromates, sulfides, and hydroxides. Most of these are insoluble. So most of these are insoluble. The exceptions, so in this case, the exceptions are the ones that are actually soluble, are compounds of the alkali metals and ammonia. So that goes back to rule number 1. If it has an alkali metal as the cation, it will usually be soluble. And that is still the case with these more complex anions. Secondly, sulfides are usually soluble when bonding with the alkaline earth metals as well, but for simplicity's sake, we are going to lump them in with these other types of anions in rule number 5. So again, These are typically insoluble, meaning they do not dissolve. They will form a precipitate unless the cation is an alkali metal or ammonium. There's a chart on page 749 of your textbook containing most of this information. I would take a snapshot of that or keep that handy near your notes, as it will be a very useful reference tool. This is a relatively simple set of rules. There are far more thorough sets that don't actually include that many more rules. If you're interested in those, I would search for it on the internet or ask me. Furthermore, if you run into an ionic compound where you're not sure, our table just doesn't seem to give enough information to determine if it's soluble. We do have a reference guide in the classroom that you can look at, or simply search for it online, and you can typically get that information. There are practice problems on page 750 and 751 of your textbook that are very good for practicing predicting precipitates, and you should go through and practice those to see if you are applying the rules correctly.